I have the pleasure to introduce Frederick Braun. Frederick is a security engineer at Mozilla, and he will talk about his diploma thesis. And at this conference, we learn a lot of new and fancy things, but this talk is about a dinosaur in browser security, the same origin policy. Frederick.
Hi, and welcome to my talk. Thank you for attending. This talk is called Origin Policy Enforcement in Modern Browsers, a case study in SAM origin implementations, which is basically exactly the same title of my thesis. So the table of contents, I'm going to briefly talk about me, then give a motivation why it does make sense to look at the SAM origin policy. I'm going to explain what the SAM origin policy actually means in terms of how it's spec'd or how it's implemented or supposed to be implemented. Then I'm going to give a few examples what is problematic with the SAM origin policy, and then I'm going to show some sort of generalization in terms of how SAM origin policy bypasses are similar to each other, and something that I found basically. And then I'm going to conclude. So very briefly, something about me. What I'm presenting is my diploma thesis from last year. If you're really interested in like all the corner cases on the citations and so on, you can download the thesis, but the presentation will probably do. I'm nowadays a security engineer at Mozilla. I still sometimes play CDFs with the team Flaxfingers from Bochum. And I noticed that most people I don't really know by real name, and they didn't know who I was until I told them what my Twitter handle is, so I put it on the slides. Okay, that's it. Let's talk about the SAM origin policy and why it makes sense to talk about the SAM origin policy. You might know this. Every website has the capability to frame another website modulo the XFrame options header, but every website can frame or reach or at least display content from another domain. And it always includes the current session. So that means that an evil web page somehow triggers your browser to render eBay.com or Amazon.com, and we've seen that it can cause a lot of troubles, for example, in Paul Stone's talk, where we actually read all the pixels. But in general, it's like kind of a critical thing to have the capability to interfere with other browser sessions, like only roughly. And the browser always happily includes all the session data, and you can see, even though I'm on an evil page, it says on eBay, this is my account, I'm logged in as Frederick, this is Amazon, I'm logged in as Frederick. And that means that browser tabs don't really stand on their own. They are always interfering with each other, basically. And as you can imagine, displaying something from eBay or Amazon is not really critical, but if the outer frame were to read what is within the pages from Amazon and eBay, it could basically like read my banking credentials or something. So that is what the SAM origin policy is defending against. It protects against access, read access from things from other domains, although displaying is somehow allowed. And if things can go wrong, you can imagine that exposing banking credentials or something similar is kind of a big deal. And then there's like a very nice example about what can go wrong with the SAM origin policy. I'm quoting here a blog post from the Mozilla security blog from October last year. I'm just going to read out the blue text. Mozilla is aware of security vulnerability in the current release of Firefox version 16, and further down it says Firefox 16 has been temporarily removed from the current installer page. So Mozilla released Firefox 16 and said we had these types of vulnerabilities in version 15, and it was, I have it written down somewhere, it was actually 14 bugs in Firefox 15, 11 of them critical with a description of what the bugs were, 3 of them high. They published this, then they published Firefox 16 and noticed this is even more insecure, and we're going to trade this one secure security vulnerability to Firefox 16, which was the SAM origin policy bypass, and tell people to download the old browser version, where we actually told people that was also vulnerable, which is the reason why they released version 16, and had 14 critical or high security bugs. But this one was so trivially to exploit that they rather had 14 memory corruption vulnerabilities exposed than one SAM origin policy bypass. because most same origin policy bypasses are some sort of API abuses and you don't have some sort of attack probability, they always work. So it does make a lot of sense to look at the same origin policy, and if something funny comes out, it's easy to exploit. Okay, so now I will actually talk about what the same origin policy is and what it means in a more precise way, except for a screenshot. So first of all, what is an origin? I think most of you know that an origin is the set of the scheme, the host name, and the port of a URI. So the origin is, so to say, an attribute of a web page that only looks or only is supposed to only look at the URI. And it always compares for read access these three attributes of URI. And if they match, access is granted, and if they don't, access is denied. And there are several terms like they are in the same origin, or these URIs are of the same origin, or they just are same origin. I will intermix this throughout the presentation. And of course, if a URI doesn't have a port given, you can always assume the default port, like 80 or 443. What some people said about the same origin policy, Adam Barth, who actually wrote the RFC 15 years after the fact that browsers had the same origin policy, that it is used as the scope of authority or privilege by user agents, which kind of summarizes the whole thing. And Michal Zalewski said in The Tangled Web, it is the most important mechanism we have to keep hostile web applications at bay, but it's also an imperfect one. And we're going to talk about how much it is an imperfect security mechanism. First of all, a small interactive part where we walk through examples, how to compare the origins of two URLs and see if they are of the same origin or not. And we'll always compare for HTTP www.example.com. So the first URI we're comparing to is this one, http www.example.com/help. I said it's an interactive part, so it's up to you to nod or shake your head. Is this the same origin? Everybody's nodding, that's fine. Okay, next URL. What about this? Okay, you're shaking your head, exactly. It's using a different protocol, it's HTTPS and not HTTP. That means the scheme is different of the URL and the port as well, even though it's not given in both cases. For the one part it's 80 and for the other one it's 443. Okay. What about this one? I see somebody nodding, I see somebody nodding, I saw somebody shaking their head. Okay, this is complicated because it's not, and I see some people disagree, we can talk about this further, but this is actually a corner case because, of course, the URL don't match, right? The origin is not the same, but the browser for this specific URI noticed that this is not really HTTP, and what is the port here? What is the domain name? How do we actually compare that? And depending on what you're going to do in the browser, access is granted or it's not, and it's actually, the origin is inferred from what you're doing with it. That means if you're just opening a pop-up which is pointing to about blank, you have read and write access to this window handle, which kind of means that it's kind of the same origin, or in terms of same origin, access is granted, let's put it that way. So the same origin policy allows access to about blank, which is not very complicated and dangerous, because about blank, of course, is the empty web page. What about this one? Is this the same origin? Does anybody say this is the same origin? No, okay. Internet Explorer does. And there are some cases where you can actually make other browsers ignore the port as well.
Which version?
IE, I think every version, but I haven't tested for a while. I don't think I've tested 11, but I'm pretty sure it's 10. Sorry? Ah, all versions? Okay. Okay. And I didn't mean to diss IE, right? So it's just. So, and now let's talk about the object hierarchy in JavaScript. I finished that part. So there's the document object model in JavaScript, which means you have.
Sorry, I have one comment on the previous slide. Don't cookies ignore the port for origin purposes too?
Yes, that's right. Dave pointed out that cookies are differently handled and not differently handled than DOM access. So they ignore cookies as well, and that's not only for access, but also for sending them an HTTP request. I'm going to come to a few more examples of that, and I want to go through the talk, and we'll answer more comments and questions later on, okay? So, the document object model. Whatever document you have in your current browser window, the whole layout of the document is represented as objects in the JavaScript code. So you have different objects depending on what the actual document shows. That also means you have some sort of hierarchy and can reach other things, like the window has access to the attribute document and location and frames, and in the example screenshot we've seen before, you have like access to the first frame and to the second frame as an object handle, but you can't actually reach into the frame. And that's actually like two distinct layers of security mechanisms, because JavaScript is an object capability world where usually having an object means you can do whatever you want with it. And then somebody puts something on top, which is some sort of access control reference monitor. So like just assuming from a system security theoretical approach, this is inherently inconsistent and sort of like a blacklist, right? Because per default, the JavaScript engine is an object capability world and gives you access to all the objects in the document, and you're supposed to reach into them. And then there's some DOM code that says, no, you don't, in certain corner cases. And whenever you implement a new API in HTML, you will have to remember that the thing that you're including from a different domain is already accessible via JavaScript, so you have to blacklist it again. And as we've seen with a few features that have come in HTML5, some people forgot about speccing that or just implementing that, and a lot of same origin policy leaks came through that, for example, with the Canvas API, where you could read pixels or see images from other origins, for example. So there are still way more APIs coming in at the browser, and I know Mozilla is kind of pushing toward that. And this is a very, very critical point about the same origin policy. Inherently, you have like a flaw where object capability and access control clash with each other. And then I'm going to talk about the exceptions that some people already wanted to point out. The same origin policy is by no way a strict or consistent policy. You have dozens of browser features that are just not subject to the policy. That means cookies are actually not port scoped at all, but domain scoped. And cookies are actually way older than the same origin policy. The same origin policy was invented, I think, 1996, when I think it was Netscape thought frames were a great idea. And then they realized it's not a so great idea if you frame other pages and reach into the content and can extract potentially private data. So they rushed into blocking certain things and invented the same origin policy in an ad hoc way. And cookies are much older than the same origin policy, so they're not really suspect to the same origin policy. Then there are attributes in the DOM which persist or which are accessible across, domains, like a window location can be set for every window handle you will ever get in your JavaScript scope, even if the window points to a different domain or a different origin. Then there's the attribute window.name, which persists across origins. Whatever you navigate the window to, window.name will not be overridden or reset when you navigate to a different domain. Then there's document domain, which is an attribute you can set, which doesn't really change the location of your current domain, but changes the so-called, in the spec, effective scripting context, which means that you can opt out of the same origin policy in terms of two subdomains of the same domain agreeing on being in the same origin, which is kind of messed up. Then Internet Explorer has the security zones, which may either make the same origin policy more stricter or more relaxed, depending on where the resource is coming from. Think of file URLs, local area network, versus the internet, the big whole internet. Then there's cross-origin resource sharing, which is a spec that allows websites to purposely deliberately opt out of the same original policy via HTTP headers, which is also an exception and makes the whole pile of exceptions bigger, but in this case it's kind of a neatly and more or less well-spec'd thing because you actually have to opt out. And then there's JSONP, which is kind of like a way to bypass the same original policy by including scripts, which are not really scripts but callbacks, and dozens more, which I could talk about for hours, but I don't think I have that much time. So we will shortly wrap up the same original policy. It's about read access to resources from different domains. It's highly vendor specific. Theoretically, it's already a bad idea to say we have an object capability world where access to every object is given, and after the fact say, oh, well, but that object you better don't read and access denied. And in general, it's highly inhomogeneous, and of course, there's no sort of reference implementation or whatever. How could there be? It was invented in the 1990s, and with the browser wars and the big competition about what to bring in your browser, there was no kind of situation where people could have agreed on something like that. So now I'm going to shortly talk about some same origin policy bypasses. Assuming that you're on an evil page and it tries to read information from a benign web page like Amazon, eBay, Facebook, whatever. And I'm going to walk through very different examples, Firefox, Flash, Java. But generally, they are all kind of similar, as you would see. So in this vulnerability from 2007, you instructed Firefox to change the current domain name to harmless.com, nullbyte.attacker.com. And the JavaScript world was kind of fine with it. It's operating on UTF-16 strings. But then the whole HTTP request and DNS code in Firefox is actually based on ASCII zero terminated strings, which thought, okay, this is harmless.com. And then harmless.com being the attacked web page and attacker being the evil web page you're on. And then instead of actually going to something that is supposed to be in attacker.com, you could circumvent it and access stuff from harmless.com and bypass the same origin policy using this vulnerability. And then there's a different vulnerability. You see it's not really theoretically different. Again, there's some sort of mismatch where the Flash plugin says, okay, this URL starts with http://attacker.com, so it's basically an attacker.com URL, right? And then it instructs the HTTP API to request this URL and parse it again. And then, oh, wait a minute, this is at harmless.com and the username is attacker.com. So again, we have a parsing mismatch between what one layer thinks and what the other layer thinks. And again, bypass the same origin policy. And then I found something similar. I don't know the CVE ID yet, but it's fixed already in Java, where you could chain the jar protocol, which is something to read jar files, like Java archives, from other domains. Or in my case, I could read stuff from other domains. Usually you shouldn't be able to. And the fact is that Java really didn't have any SOP code for the jar protocol. So you could basically read any kind of jar archive from other domains. The funny thing is that the jar specification says a Java archive is a zip file with optionally a manifest file in it or no manifest file at all. That means I could read every kind of zip file from every other domain using this bug. And by just prepending jar colon. And I'm going to give a very quick demo. So the funny thing is, since this is a bug since this is a bug in Java in a plugin, it doesn't really matter what kind of browser you're using, right? It always affects the browser, although the browser is safe, the plugin is not. So I can demo it to you in whatever browser you choose. I have Avant browser, Firefox, Chrome, Yandex browser, Nightly, Opera, Safari. You get a pick. Somebody shout. Yandex. This is Russian, but probably about translation, I don't know. But okay, this is the exploit, and you see this is the context of an XML file, which is the Office document linked above and somewhere is like the actual text, which is, oh hell, this is so confidential, let's hope nobody read this. The key is chocolate at dawn. And as you can see, the content of the file is actually that. So we did read from another domain. I think we might have time for one more example if you're interested in another browser. Sorry? Chrome. Where is it? Ah, there. Fancy demo. Okay, Chrome has click to play, but people click. Okay, here's the same. Well, yeah, that's the demo. So now we'll come to a conclusion. The same origin policy is highly inconsistent. It's very vendor-specific, as I said before, and theoretically speaking, it's just a blacklist of access control mechanisms thrown on top of this object capability world. And then there's plugins. So whatever browser you're using, and if you're saying, okay, I'm just using one browser, so I don't care about the inconsistencies, you always have some plugins in there, right? I mean, at least you gotta have Flash for YouTube. And you already have two different implementations of the same origin policy, which might disagree with each other, and then vulnerabilities may come up. And these are statistics I have from last year because the thesis was worked on last year. Java was active in 70% of all browsers, even though it was used on only 0.2% of websites. So my suggestion would have been, why not just disable Java or something? But then something funny happened in early 2013 with a lot of Java exploits, and most browser vendors actually helped you in not having it activated by default, which is a good thing, I guess. But there are safe and well-designed security models on the horizon in terms of iframe sandbox and CSP, which are way better and well thought out in comparison to the same origin policy. Future work, it would make a lot of fun or sense to automate this because you can easily do all the critical or potentially vulnerable JavaScript calls and try and catch blocks, and you don't actually have to like restart a browser or something. You can just automate it with JavaScript, and in contrast to some fuzzing automation, you don't even have to restart the browser and have some crash failover or whatever. You can basically try to read stuff, and when it works, you kind of log your vulnerability and go on, and if it doesn't, you probably jump to the catch block. So I think it might be worthwhile to automate same origin policy checks or a test suitcase or whatever. And then I have something funny on top. Someone in stackoverflow.com said, I was looking for quotes for my thesis. The same origin policy is the dumbest thing ever. All this protection serves to do is to aggravate legitimate developers trying to get JavaScript to do the simplest of tasks. I'm pretty sure we don't agree here. But legitimate developer is kind of like a nice phrase. Should get a t-shirt, legitimate developer. Thank you. There are some references. There are way, way more, which are online. Any questions?
Yeah, thank you, Frederick. Dinosaurus lives forever. Any questions?
None?
Really?
Should have brought chocolate.
Okay, Thomas.
Maybe just a short remark that it's not just inconsistent, but also suffers from an interesting disparity between standards and documentation. So the RFC by Adam that you mentioned is really about the concept and then gives you a rough sketch of what the policy says. The policy itself is actually specified in HTML5 for a great number of things, but probably not for everything. And then the additional question becomes what exactly is implemented. And so I'm very glad to see this work and would just like to find ways to make that more prominent as documentation of what exists and as an overview. So thank you for doing this.
Okay.
Yeah. Thank you, Frederick. Thank you. And now we have a 4 minutes break.
Coffee. Thanks.